Well, welcome back and greetings, nerd and nerdettes. Let's continue on with our next video here, and we're going to talk about branch statements in assembly language, in ARM assembly. Well, just jumping in, let's just kind of reflect a little bit. Well, what is a branch statement? Branch statement is a term for really effectively anytime you have branches in the control of where the program logic might go. Okay, so like if you think about the simplest example I could kind of think of is imagine you've got in C or some other language, right? You've got a conditional statement, right? An if statement, okay, and you're doing maybe something like this, right? And then maybe you have an else. We've got a situation here in which only one of these two code blocks is going to be run, right? Either this code block 1 or code block 2, right? The logic of the program will never hit both of those. And so that is an example of a branch, right? Anytime that you have some sort of if statement, it actually can also be with loops, is where the control of the flow of the program is branching out in a different direction. So you can think about it as if like your program's running, it's running along, it's kind of moving along, right? And then you hit a scenario where you have, right, if A is equal to 0, you're going to go and you're going to run that code block 1, okay? Else, you're running code block 2, and then they kind of the program that merges back together, right? So we've got branching off anytime that you have some sort of conditional statements or some sort of logic checks in which you're going and you're going different paths, you're running different code blocks, running different lines of code. That's where the term comes from. Okay, and so at a very kind of essential part of any sort of branch operation is comparison, right? That we want to compare some logic, we want to do some logic, determine we want to evaluate some expression to determine if something's true or false, to determine whether or not, like, true, we go to this branch, or false, we go this other direction. Okay, so in this case, the true false we're seeing is A equal to 0, right? We're evaluating true false to determine if we're going to hit this code block or this code block. All right, so at the heart of a comparison, we're going to learn something new in terms of how we're going to be able to do this in ARM assembly. We're going to look at how we can compare two register values, and we're going to do that just using something called the CMP instruction, or the compare instruction. And very, very simple in terms of what effectively we're doing is we've got two things, right? We have the instruction itself, right? We've got the actual instruction, okay? And then we have these two operands, these two parameters, right? We've got our two registers, okay, that we're checking, okay. We could also, or that we're comparing. We could also do something where we have a single register and using the pound symbol, right, checking against some value, right, some number, right, pound and then a number. This is something that's referred to as the immediate, right? An immediate value is that you're not actually storing it anywhere, like in a register. It's actually stored as part of the program itself. It's some like hard-coded number that's actually stored with the program. And so you could also do that. And the key syntax is when we're using an immediate is we use this pound symbol. Okay. So, well, one thing that you might notice that's a little strange when we're using this compare instruction is, where does the result get stored, right? We're comparing R0 to R1, and it's not really clear just looking at this well, okay, you're comparing it and then what? Where is the information about what's different about those values getting stored? Okay, and so they by default get stored something is referred to as the current program status register, CPSR, current program status register. And what we're going to be focused on right now is only, at this moment, I only really care about two of the bits in that register. All right, we're going to kind of temporarily ignore the other stuff, okay? Just these 2 bits is what we're concerned about at the moment, the n bit and the z bit. And so when we do a comparison, like I just showed in the previous slide, when we do a comparison based on the values of R0 and R1, if we do this, right, if we do compare R0 and R1, what happens is underneath the hood, right, what's actually going on in the processor is that R0 is going to get subtracted by R1, and we're going to look at, and then the result is looked at. Okay, this result. Okay, if that result, okay, is positive, right? If it's positive, the n bit standing for negative will be 0 for false, right? If it's a positive result, right, or it's not a negative result, so 0 would also set it to 0. That would get set to 0, right? If R1, and this is how it's used, is to determine basically if R1 is larger than R0, right? So if I had something like, obviously here, if I put in some real numbers, like if R0 was 5 and R1 had value 10, right, and we have the result is -5, right, since it's a negative number as the result of that subtraction operation, we would set the n bit is set to 1, right? And that tells us that this R1 is storing a larger value than R0. Okay, that's what that bit would tell us. Okay, now if the result of that subtraction is 0, right? If R0 minus R1 results in 0, right? Then we know that R0 and R1 must be equal, right? And so if the result is 0, we set 1 here for the z bit, so effectively the n bit is letting us know if one register is larger than the other, and the z bit is letting us know if they're equal. Okay, that's effectively what's happening there. Okay. So if we kind of look at an example here, now we're going to pretend like we're looking at the compiler, right? That is, if we had this C code here and that we went and compiled it into assembly language, right? And it's going to look something like this, right? It's going to look something like this. And I'm going to actually show this in a way that's kind of more consistent with what we've seen so far. Is I'm going to kind of rewrite this expression as R10 set to 1. It's really doing the same thing as what I'm getting there, but I'm going to write it that way. Okay. So what's going on here? Let's take a look at this, right? And I'm going to, to kind of make it sink in, I think I might use, why don't we, well, we'll see it in terms of real values. We'll look at it 2 different ways, okay? Let's imagine that R9, that register, let's just assume that it has value 5, right? Hypothetically, okay? Well, what happens here on this line, when we go and run the compare, is we're comparing. We're saying R9, we're going to compare it to the immediate value 0. We effectively do 5 minus 0, okay, and we look at that result, which is obviously 5, right? The n bit in the current program status register is going to be 0 for false because that result is positive, it's not negative, right? And the z bit for 0 is going to be false because that result is not 0, okay? Then when we hit this line here, BEQ, this stands for branch equal. And what we're getting at is if the branch equal will do, this instruction is it checks the z bit and says, is it 1 or 0? Okay, is it 1 or 0? Okay, if it's 1, it means that the previous comparison was equal, and so it's true. Okay, if it's 0, okay, it indicates that that is indeed that they're not equal. Okay, so in this case, since it's 0, it then falls into this line here. We go ahead and we set R10 to 1. Okay, However, if we had something different, right? If R9 happened to be, if we initialized it to 0, we would then have 0 minus 0, and the result is obviously 0. Okay, the n bit is still 0 for false because it's not negative. We're actually not really concerned about that in this case. But the z bit would be 1, indicating that the result here was 0. Okay, and in that case, right, that occurs when we run this comparison. When we check the branch equal, right, now that's true, and we're going to go here where it says end if. This is something called a label. Okay, a label. Okay, the label is just a location in the program where we branch to or we jump to. Okay, so we effectively skip this code block here. Okay, this code block here where this move operation is. Okay. Now, I want to point out an extremely, extremely common issue that people make, a problem that people make, is that this is worth really pointing out explicitly because it's confusing, and I take a moment to really let this sink in. Okay, notice what you probably did already is notice here this is showing not equal. Okay, notice here it's checking equal. Okay. That is not a typo. I've had people ask me before showing similar examples being like, is that a mistake in the slide or something, or a mistake in the example? It is not. It is not, okay? This is counterintuitive, but let's think about it for a moment, right? When this expression is true, right, what happens? We run this code block in here, okay? So when this expression is true, we run this code block here, okay? In assembly, right? And we're looking at this. When this is true, we jump to this label. We skip the code block. It's the opposite. Okay? It's the opposite. Hence, the logic for determining when we're entering the code block or not, or when we should, is the opposite, right? It's a negation of the logic from the C example. Okay? So that's a very common mistake to make. Now, there's a reason for this. It's not to make your life difficult seeing it this other way, right? Remember, when we're doing stuff in languages such as C, they're designed to be more readily friendly for human programmers, okay? Assembly is not really designed to be something friendly to code in, right? It's much closer to the underlying hardware. It's giving you a sense of how the hardware is actually processing these instructions and running the program. Okay, and so you can kind of think of it as more machine friendly than human friendly. Okay, and so how it's actually running is we're checking the opposite of what you wrote, and then we skip everything that's in the code block. Okay, we will get a better appreciation for that later when we actually look at the ARM processor and trace things out. Okay. And this is similar in other processes. It's not something that's unique just to ARM. This is the kind of a common way in which these are built. Okay. Right. We'll look at a similar example here. Right. I'm just going to rewrite this to be more friendly to what we've seen so far. Right. It's the same thing. I just want to change that one line here. Okay, in this example, we're looking at equals here in the C example, and that what we do is we look at not equals here. Branch NE stands for branch not equal. Okay, notice, right? Notice it's a negation. Okay, it's a negation. Okay. Right? To get the logic to do the same thing from the C to the assembly example, those need to be the opposite. Okay, and again, remember, when this expression is true, we run this code block. When the expression is true over here, we jump to the label. Okay, the label, by the way, I happen to call it endif. You can call it whatever you want. Right? I made that name up. This is a name that somebody writing an assembly has a discretion to call it something. Right, as long as it's a unique label, right? As long as it's something that you've created, the label's not conflicting with an already existing label that's somewhere else in the program, you can call it whatever you want. Okay. Now, obviously, you want to try to make them descriptive so you don't drive yourself nuts trying to figure out what things are doing. Okay. It does not need to be called endif. Okay. I just try to give it a descriptive name. All right. Okay, we already saw that. Let's go. Okay, I'll show you this quickly, and then we'll do an example that we'll build kind of together to make this sink in a little bit more clearly. Here, if I'm doing like a if-else, it's important that I also include this unconditional branch. Okay, just given the letter B and then the label will, there's no comparison, there's no checking. It just go to that location. You just like no questions asked, just immediately jump to here to line 8. Okay, and we need that, right? Because if we didn't do that, the code, if it fell into this code block here, it would just keep running and it would run this. Okay. All right, so that's just to kind of point that out, right? You think about it. If we didn't do that, right, we would run line 4, right? And if we didn't have line 5, we would just jump right down and keep running and then run line 7, which just doesn't make sense. All right, so if that didn't sink in, that's okay. Let's do this together. Let's do one that we'll write from scratch. Okay, and I'm going to write this using T0 and T1 just to kind of keep the register names the same. Okay, so let's take a look at this. Let's do it line by line. We've got the C code, and we're going to write the equivalent ARM code. All right, so the first thing that we need to do is we need to compare. Okay, we're going to compare registers T0 and T1. Okay. Now, after I've compared them, the N and the Z bits are set appropriately. Okay, that we saw earlier, right? Current program status register, the N and the Z bits are set the moment we hit that, we run that compare instruction. The next thing we want to do is we want to do the opposite of what this logical operation is doing. So this is a less than. I don't want to branch on less than. I want to branch on greater than, equal to. Okay, BGE, greater than, equal to. Branch on greater than, equal to. If it was just branch greater than, by the way, it's BGT instead of E. All right, I'll give you a list later on so you can see all of them, but they're usually pretty easy to remember. And I'm going to say if we hit that, let's call the label, we'll call it something nice and easy and descriptive. We'll call it to go to the else if. Okay. Right, that takes care of this line here, except I haven't defined the label yet. Inside of that code block, we'll have a move into T2, the value 1. Okay. And then what will be very important is I need an unconditional branch here that if I ever hit T, this line, after running that line, we want to go all the way to the end of that whole if, else chain, right? You're only going to hit one of those code blocks. You're only going to hit one of the, in this case, 3. So if you hit one, you immediately want to skip the other ones. You never want to, it wouldn't make any sense to run more than one of the code blocks here. Because this was, we already know that in that case, this was already true if we ended up getting there. Okay. Then we've got our else if label that I called before, right? If this is true, if it's greater than, we're gonna go here. Okay. And I could do the comparison again, the CMP. I actually don't have to, right? I've already compared these same two registers up here, right? And nothing else that this code could have done between here and here could have called a comparison and reset the N and the Z bits. Okay. So I don't have to do the comparison. It actually doesn't hurt if it makes more sense to you to do it, to go ahead and do it that way, but it's actually not necessary. Instead, I could just immediately do my next branch because we already have the N and Z bits set correctly. Okay, and we haven't changed T0 and T1 anywhere from here to down here. So I can now say we've got the greater than symbol here. So I want to do the opposite of that. Instead of greater than, I want to say less than equal to. Okay. And we'll call it else. Will be the location where it goes. Okay. Then I've got inside of that code block, Okay. If I hit that code block, I need to skip to the end. Okay. And then I have our else. Okay. And then we're done. I don't need, right? I've seen people do this before where they add another branch end if here. It doesn't do anything, right? I mean, you could put it there, but it's not necessary, right? Because the moment this line's run, it's going to that location anyway, right? It's kind of redundant. It's not, so it's really not necessary to have that. Okay. All right. So there's some example using conditional statements for from an assembly perspective, right? This is going to give us a bigger understanding of how hardware works when we end up looking at the ARM processor in some subsequent lessons. But before we do that, one of the next things we're going to do is we're going to look at loops. We're going to look at how loops are compiled into assembly language. We'll look at both for and while loops. And we're starting to build up some kind of prerequisite knowledge before we're able to kind of look at the processor itself, okay? All right, so thank you for watching. Take care. Come into class with questions and be ready to practice this. And don't hesitate to ask questions because that's the best way to learn.